There's a photograph of you. You're maybe 2 years old. You're smiling, you're holding a toy, you look alive. But here's the thing. That child in the photo, you have no idea who they are. You lived through their entire life. You experienced every moment, but you don't remember any of it. Not a single day, not a single moment. And when people ask why, they give you the obvious answer. Your brain wasn't developed enough. You were too young to form real memories. But that answer is wrong, and the truth is far stranger. Because your baby brain wasn't failing to record your life. It was recording everything. Your memories were there, encoded, stored, real, but something destroyed them. This phenomenon was first named in 1905 by Sigmund Freud. He called it infantile amnesia, but for a long time, no one knew why it actually happened. Then, in the 1980s, a psychologist named Carolyn Rovee-Collier ran an elegant experiment. She took newborn babies and tied a ribbon from their ankle to a mobile hanging above their crib. The babies quickly learned that kicking made the mobile move, and they loved it. She brought the same babies back days later, and they remembered. They started kicking immediately. 2-month-olds held that memory for a couple of days. 6-month-olds? They remembered for weeks, so infant brains can learn. They can store information, they can recall it. But those memories don't last. By adulthood, every trace is gone. And for decades, scientists couldn't figure out why. But there was an answer. And it started with understanding a tiny structure deep inside your brain. The hippocampus is a small, curved structure, and it's the engine of memory formation. It's what allows you to take a lived experience, a birthday, a conversation, a moment with someone you love, and encode it as an episode you can later replay in your mind. In adults, the hippocampus works with the prefrontal cortex. Together, they tag, store, and retrieve these episodes. But in infants, this system is severely underdeveloped. The connections between the hippocampus and the cortex are still being built. Key regions like the dentate gyrus, which acts as a gateway for new memories, aren't fully wired until somewhere between ages 2 and 4. So your infant brain could form short-term memories. It just couldn't move them into long-term storage the way an adult brain does. But that's only half the story. And honestly, what comes next is even stranger. Because in 2014, 2 neuroscientists in Toronto discovered something that changed everything. Sheena Jocelyn and Paul Franklin were studying infant memory, and they had a hypothesis that sounded almost absurd. What if the very process that builds your brain is also what destroys your memories? Here's what they meant. In the first years of life, your hippocampus is producing new neurons at an extraordinary rate. This is called neurogenesis, and it's essential. Those new brain cells are what wire up the circuits you'll use for the rest of your life. But Jocelyn and Franklin suspected there was a cost. Every time a new neuron integrates into an existing circuit, it disrupts the connections that were already there, the connections that were holding your memories. To test this, they ran experiments on mice. When they artificially increased neurogenesis in adult mice, something unexpected happened. Those mice started forgetting things they had previously learned. They couldn't remember tasks. They couldn't retain training. And when they slowed neurogenesis in infant mice, those infant mice held on to their memories longer than normal. The results were published in the journal Science, and they pointed to a deeply counterintuitive conclusion. Your baby brain wasn't too weak to hold memories. It was too busy growing. The same explosion of new neurons that built your brain also overwrote the memories stored inside it. Your earliest experiences weren't lost because they were never saved. They were lost because your brain kept building new rooms and tearing down the old walls in the process. But there's another layer to this, and it might be the strangest part of all. To form what scientists call autobiographical memory, the kind of memory where you are the main character, an experience you can replay in your mind like a story, You need something most people take for granted. You need a sense of self. You need to understand that you exist as a person, separate from the world around you, that things are happening to you, not around you. Developmental psychologist Mark Howe made a crucial observation in the late 1990s. Before roughly 18 to 24 months of age, infants don't recognize themselves as distinct individuals. The classic test for this is simple. Put a dot of rouge on a baby's nose and place them in front of a mirror. Before 18 months, babies treat the reflection like another child. They don't reach for the mark on their own face. After 18 months, everything changes. They reach for the mark on their own face. They recognize that the person in the mirror is them. And that moment, the birth of self-recognition, closely tracks with the earliest age at which autobiographical memories can form. In other words, you can't remember being a baby partly because there was no you yet. Not in the way that you experience yourself now. There was no narrator inside your head packaging experiences into a story that belonged to a person called you, which raises an uncomfortable question. If you had no continuous sense of self, and the brain that held your earliest experiences physically rewired itself beyond recognition, is the baby in your old photos actually you? Or is it someone else entirely? Someone who lived in the same body but whose mind was literally disassembled and rebuilt, neuron by neuron, into the person you became. There's one more piece. Language. Developmental psychologist Catherine Nelson spent years studying how children form lasting memories. Her conclusion was revolutionary. Language doesn't just describe our memories. It structures them. Before you could speak, your experiences were encoded as raw sensory impressions, sounds, textures, emotions, light. But without words to organize them, those impressions had no framework to attach to. Once children begin speaking, and especially once they begin having conversations with adults about past events, remember when we went to the park? Do you recall what you were wearing? Their ability to form lasting memories improves dramatically. Language gives memory a skeleton. Without it, experiences are like water with no container. They exist in the moment, then they're gone. And this isn't just theory. Psychologist Chi Wong at Cornell found something remarkable. The age of your earliest memory actually varies depending on your culture. In Western cultures, where parents frequently narrate their children's experiences, earliest memories tend to start around age 3.5. Among the Maori of New Zealand, whose oral tradition places extraordinary emphasis on personal history and storytelling, average first memories reach all the way back to age 2.5. In some East Asian cultures, where early childhood narratives focus less on the individual, first memories tend to start closer to age 4 or later. The culture you grow up in literally shapes how far back your memory reaches. So here's what actually happened to your earliest years. Your hippocampus wasn't ready to build long-term memories. And even when it started to, the flood of new neurons tore through the circuits that held them. You had no concept of self to anchor experiences to, and you had no language to give those experiences a structure that could survive. It wasn't one thing. It was everything all at once. Every human being who has ever lived went through this. Every person you've ever met has a black hole where the first years of their life should be. And the answer to why isn't that your brain was too simple. It's that your brain was doing something far more important than remembering. It was becoming you, and that required, quite literally, destroying the person who came before,